2 down there gives me a VA of x equals 2. There you go. So from that, we know C is -2.
For number 1, how would we know, like, for the first limit, how would we know, like, which part of the graph it was?
The leftmost part of the graph. Like, negative infinity's over here.
Yeah.
So as you move this way, which would
yeah,
be that piece of
I
the
get
graph. You know what I mean?
Yeah, I get it.
Okay, HA at y equals 3. What does that tell us? Right, ratio. And then to have a 0, doesn't that mean that's when y is 0? So it's at the top 0. So you'd say ax plus b is 0. Well, we know now that a is 3, x is 1, b is what we're looking to find. So b is negative. Yeah.
Just real quick on the first one again, it's when it has like a number on the right side of the middle number, that's from that way.
From that way.
It's a positive from the right. Okay,
Yep.
I mean, forgot that.
Okay.
This was a review quiz and we just wrote it out in the formula, would that be fine?
With what?
We just wrote it out in the formula. Like, I know this is-
Oh, yeah.
Just wrote it out.
Yeah. All right. And then true. How many said true for number 3? And how many said false? Own it. Just whatever answer you have. And the rest of you aren't sure?
Yes.
Did those of you that said false, did you rewrite this? Are they the same?
Yeah.
Their graphs would look exactly the same? Grant, what do you think?
There would be a hole
Where?
at 3.
Yeah, they're almost exactly the same except for that one little hole in G. Okay, so this is false. G has a hole at x equals 3. F does not. All right, that's day 3. We need to finish 4, 5 first. Yeah.
Oh, Lord God.
Is it like an hour?
This is Mikey, I moved my seat. I can better see what Paul's not moving from this seat.
Okay.
No,
Because they've been working on
No, it actually wasn't.
No, Mom, I used to for how Mom pronounces his name. Marsha or Marcia.
All right. So
Marsha, I think she said that.
it seems most of you were productive yesterday. At least you got the 4 done, most of you, yes?
Yes, Marsha.
On 4th work?
yeah, I remember the last half, but I was trying to figure out why I didn't know anything.
Talking about the review.
Yeah, I know, because I haven't taught you yet. And guess what? You're gonna learn today, so. But I said that, what did I say?
I forgot.
You just don't
Okay.
listen.
We have a weird stuff.
I know, or something.
I've heard.
I started like,
Do you know Mr. Beadle?
no.
I'll enlighten you sometime about Mr. Beadle.
Why don't we do it right now?
I like
No, let's not.
Mr. Beadle told me that girls are statistically worse at math.
All right, you know what?
He talked about 90 Day Fiancé the entire time.
You know what I did? I had
We talked about Atari and Monty Python.
You know what, Mikey, I have to be honest. I steered clear of him and I let him hang out with Paul.
I
because
love
I
him.
was really tired of Paul yesterday.
And she didn't need to.
And I,
It's
so,
over there.
Okay. You know, here's the thing, I told the first pre-cal class, I said, I'm just happy to have a sub.
Like-
Have a human in this room that's able to be a sub because we are so short on subs lately.
You have to use Pac-Man.
I couldn't go to a training that I had because there was no sub for me.
Weird or not, I just need a person in here,
I like him.
I'm sorry.
He's good. You know, he's not a bad guy.
I like him.
He is.
Anyway,
Kind of like.
real quick.
Me and him had a really in-depth and really interesting conversation about the economics of hot dog stands in New York. And it was like
We had one about the economics
This
of
is like
Venezuela and Atari and Monty Python and Moore's Law.
This is my potato cakes.
I don't know.
Good. Like, she's like trying not to.
Team Mom.
No,
It's okay, Mrs.
I already heard weird stuff earlier about him. So. Okay.
At least we didn't have Mrs. Whitaker.
Also kind of
She's mean.
No, he gets the job done. It does exactly what I thought.
scares me.
No.
Like, what?
Alright. We need to keep going. Okay. So we ended, I feel like we left on a cliffhanger because we grabbed cosecant, but then we didn't grab secant yet.
I mean, that's okay.
I need to
Okay. So, just to speed this along a little. Do you remember how cosecant's friend is sine, right?
Yeah.
And we use sine to help us grab cosecant.
Yeah.
So what do you think happens when we want to grab secant?
Use cosine.
Cosine. Okay. So, here's stuff in the first class, because we were a little ahead of you guys. So to graph secant, you need to graph cosine, okay? So same scaling as your cosecant graph. And remember, is the dashed part actually part of the graph? No, it's just helping us graph the actual graph. So we have 2 pi, negative 2 pi. So go ahead and graph cosine, that in red. And how do we get the asymptotes again? How do we know where the asymptotes are located?
You know, I think Team
Yeah, the zeros. And remember, that makes sense, right? Because wouldn't secant be undefined where cosine is 0? So all the places where cosine is 0 are your asymptotes. And then your actual graph is off the high and low points, the maxes and mins of the cosine graph.
Michelle. It'll be okay. Can't handle it.
I know.
Well, that is the one that
Yeah. You know what?
statistically he's right, so listen, we are moving forward. Listen, I don't want to get so topic again, but listen.
Drugs.
So when I was here as a student in AP Calc, like I was one of 4 girls in my Calc class. now I have at least half girls in my calc class.
I wish I would have heard him say that. How did I miss that?
Yeah, I wish I
Statistics are
would've
really
really
good underneath.
Like would have dragged him to the
Yeah.
grave.
Yeah, more than half of my calc class is girls.
I was joking.
So, and more girls go to college, so probably.
I mean, if you
So,
I thought that more men would go to college.
Listen, this isn't the sixties.
Oh no. Things still suck. Take, for example, our lack of a lady president, even though every other country has one. Yeah, but that makes the problem even worse. That means you're being oppressed. You don't even have to be a minority to be oppressed. You just need to have a China. No, I didn't.
if you wanna kind of mention.
His face.
Okay, we're gonna move on. So now, let's practice graphing a couple that have been transformed. Okay, so if I want to graph cosecant.
Yeah, I don't care.
Alright, well,
I was in CT.
okay. If I want to graph cosecant, what do I need to use to help? Okay. Okay, so we need to graph y equals 2 sine of 2x. Now get your brain back into sine cosine, right? What's the period formula for sine and cosine? Okay, what's b? 2. Okay. This is our b. This is our a for our amplitude. All right. So 2 pi over 2, that's our pi. All right. So every 4 is pi. And I'm totally fine if you want to kind of start labeling every other, just so it's not so messy, since we got a lot going on.
Thank you, Mrs. Meyer.
You know what? You're welcome.
One day you can choose her on that.
You know what? I'm realizing you might be my new Jacob Kirby in some way.
You know, he's kind of making me sick a little.
Uh-huh.
Whoa.
Shut up, Nick. Not all of us
Nick
love
Mankowski. You mean Jacob Hervey's like Nick Mankowski?
I'm so confused.
In a different way.
In other words, Eddie Haskell.
Yeah.
I can't imagine that.
Jacob Kirby would, like, he's so polite, you know?
He is.
Yeah.
He would ask me every day, can I use your 3-hole punch? And I would, after a while, I would say, could you go use it? You don't have to ask me every day. You know what I mean? That kind of thing. So it's like a different thing, but
But
it's
it's
like.
still irritating.
It's the same.
I love Jacob Hervey.
Of course.
Who doesn't love him?
You ask me every day, so.
Remember his circles theorem, his concentric circles?
I'm not gonna say no. It's like,
Yes.
Hey, can you connect? I'm reminded of him because my calculus class wanted to see my rap battle with him.
Oh my.
We do not have time for that
Aw.
today, but I promise. If you haven't seen it, I will show you maybe next week. My rap battle with Jake Kirby 2 years ago. Okay.
wait, can we do it on Tuesday?
Mrs.
We'll
Spurgeon
see.
is only 15 years old.
That'll be on Monday.
She's too afraid to rap out.
It'll give you something to look forward to, but we don't have time today.
Yeah,
Okay.
on Monday we'll see the rap battle.
I will
Sine.
remember that.
Okay, sine. So sine starts here, right?
Yeah.
And does its thing. Now I am going to have this graph dashed. I'll make a deal with you though. If you're, if we get done early and we have 6 minutes, I'll show you today.
That's a long rap battle.
Okay, so there's sine. So then the zeros of sine are going to be the asymptotes of our cosecant graph.
Cosecants.
That is not what I said.
The second. Cosecunde.
I gave you some, I put it out there, but we'll see.
I don't understand why people think I'm so amusing.
Not.
Exactly.
Okay. Where's the first asymptote? Like, the first nice one? 0. What's the distance between the greens? Okay, so how can I smush them together and take all my vertical asymptotes? Hi, I was getting into this. Did you notice the distance between asymptotes was half the p? Yep, that'll always happen with secant, cosecant. So you may, if you want to note to yourself, that's half a p. And again, I should have put domain and range instead of transformation, so change it for me, please. Domain is going to be everything but those places. And then remember, the range is the green. So from negative infinity up to -2. And then from 2 up to infinity.
My graph is horribly asymmetrical and I do not care.
That's good then. If you doesn't have to be perfect, it's just a sketch. Any questions?
When will we do this in real life?
Maybe later though.
You know, sine and cosine graphs are really like radio waves and like things like that, sound waves, but secant and cosecant, not so much probably. Okay, if I want to graph cosecant, what do I need to help me? Cosine. Okay, I want to graph.
How do you just get cosine like that?
What's that?
Oh, never mind, I get it. I was confused for a second because I didn't understand how you just made it get cosine, but then we're graphing cosecant so that we can get cosine. That's why it's dashed.
Yeah.
I don't hear laughing.
Okay. What's B on number 2?
Okay, well.
4. So our period is 2 pi over 4, which is pi halves. So 1, 2, 3, 4 is pi halves.
So what do you need to do? Turn it up.
Why are we graphing the cosecant?
We're graphing cosine.
Oh,
Because Cosine and secant are friends, right?
Oh.
They help each other graph. Well, mostly cosine is really the leader.
I do it slightly differently. I just
Okay.
put the cosine part 1 over and leave the rest normal, and it works.
Okay. All right. Now, this is a good review of what we did on Tuesday. So now you're going to do your midline. That's your down 1. From that midline is where you use your amplitude. What's the amplitude? 3. Up 3, down 3. So 1, 2, 3. Now it's going to get crazy. There's going to be a lot of dashing. If you don't like all the dashing, that's fine. I just like to stay organized with my graph, or I'm going to put a dot in the wrong spot.
The dashes are fun to draw.
I wish it was a smart board where you could just make it a dotted line.
I guess I could. I never do that though.
Really?
Silliness is my key.
Oh.
I wouldn't
All right.
really draw it for that.
Being a lot more.
Cosine. Does cosine start centered or up? Or down or? Okay. Just making sure. So cosine starts up here. And I like it because now I know all my green dots need to be on the dashed lines. Grant, did that help? I know someone wasn't shifted left or right, but
Yeah.
you with me? Okay. So here, here, here. So there's one cycle of cosine.
I love how good you are drawing dotted lines.
Look at it a few times.
Yeah, a few times maybe. Like 8 years in a row. Yes, thank you.
Which one?
The other one's in here.
I know, but I'm just saying, they both do it.
Oh, he had surgery.
Oh. So he was here this morning and then left early.
He came in and got his notes like a responsible young man.
Aw.
I'm very
We're
responsible.
responsible if somebody reminds you 1,000 times.
Okay. Now your zeros are now, your midline has moved, right? So your zeros have moved down, okay?
You're so beautiful.
So those purple,
You're beautiful.
I gotta go.
You're beautiful.
all right, let's keep on task.
Oh my God.
Okay, the purple is gonna be our final graph, so here we go. Here, down, up. The actual graph is all in purple. Asymptotes are in purple. The graphs are in purple.
I am very proud.
Mine's all in pencils. Mine's all in gray.
But you're still.
Have you seen that?
Okay. All right, guys, where is that first asymptote? High eights. What's the distance between the asymptotes? Yeah, half of the period, right? 5/4. Okay. High eights plus 5/4. Okay. Domain, all reals, x not equal to pi eighths plus 5/4. Okay. Looking at our dash lines here, this is -4, this is -1, this is 2. So up to -4, you know what, I'm gonna put down here real quick. Negative infinity to -4, bracket, union, bracket, 2 to infinity. There you go. All right, so that takes care of secant and cosecant. We have one more thing to do. No, we still have forcing to do.
We don't have to do 4 6.
Yeah, we do.
Not good.
Guys, just remember, we
I wanna
did
play
not
my
do
history
one
teacher
drop
today.
day. So let it be your motivation. Yeah. It can happen. We still have 31 minutes. Ready? I'm moving.
One more slide.
Okay.
Don't move it. I missed it.
Oh, I got one.
All right, we've actually done this before. I'm just kind of changing the quadrants up on you a little bit. You had this on your last quiz,
Yeah.
where you had to give me the angle measure that gives you the ratio. And the one thing I noticed that you forget to do, if it was given in radians, you need to answer in radians. You got docked for that, just a point. All right, first of all, can you tell me what quadrant this is? 1, 2, 3, or 4? 2, because this is 90, right? And this is 180.
Bless you. Thank you.
So in quadrant 2, we're drawing our triangle with the ratio 2/1, hypotenuse over.
I still didn't finish it, but whatever.
All right, flip it and we'll come back.
You can stay on task.
I can stay on task. I just want to see try to throw away.
Okay, so from last section, if the hypotenuse is 2 and the opposite is 1, what's the reference
Oh, I
table?
did.
30.
Okay, but you still have to take notes.
Okay, now, here's where some of you went wrong on the quiz. Some of you said 30. Is this angle in red 30?
No.
It's actually in quadrant 2. In degrees, what's the angle? 150, right? Which still would have gotten you 1 point off because that's the answer in radians.
Uh-huh.
Okay. That was a 4-point question, so you only. Yeah, a couple ways, you can just old school it and convert it,
I'm just stretching.
or 30 degrees, right, would be pi 6. So if you're here, that's 1, 2, 3, 4, 5.
Why is it the 150 angle that we're using? I mean, why do we use 150?
Because you're in quadrant 2 here, this is 90
Yeah.
degrees,
But why do we use 150?
because 150 is in quadrant 2,
But so is 30 degree thing.
but 30 is not in quadrant 2.
What quadrant is it in?
1.
Oh, I was reading it wrong.
This in red is 150.
Okay, so it goes clockwise,
Yeah, no.
counterclockwise, but 30 is in the top left. Top left is quadrant. Oh, it goes counterclockwise from right to left. Starting at the top right, it is in quadrant. Wait a second.
This is 0 degrees right here, Paul.
Yes. So quadrant 1 is in the top right.
Yeah.
Quadrant 2 is in the top left. Then 30 is in quadrant. That's what I thought. But see, then 30 is in quadrant 2.
No.
Why not?
This is 0, this is 90.
Oh, we would have to move it around.
And because of this.
Oh, now I get it. I'm sorry. I was looking physically where you positioned that angle.
Okay.
That
I see.
particular angle.
Are we good?
Yeah, that was confusing.
Okay. What's pi in degrees? What's 3 pi over 2? What quadrant is that? Boom. Okay. So. Secant is h over a.
H over A.
H is going to be the red 2. Adjacent is the -1. So what's our reference angle this time?
Sorry. I'm listening to what she's saying, though, making sure I understand.
So again, what's the actual green angle in degrees? 225. So you can convert it if you want by multiplying by pi over 180, or you can.
Wait a second. How is it 225? We've got like don't we count the 45 that's in the triangle out?
We are. This is 180.
Oh.
45 past 180 is 225.
Oh God, I keep looking.
So in radians, what is this?
I am.
1, 2, 3. Yeah, 5. How many of you like to convert it? How many of you like the pieces, like 5 or whatever? Okay.
How many of you like tonight?
Is it 5 pi over 4?
5 pi over 4 is the answer.
Yeah.
All right, one more. What's negative pi in degrees?
Oh, I'm lost. Thank God. I am.
Wait. Negative pi is, okay, and negative pi halves? Okay, now what quadrant is that?
2. Oh, 3.
Yeah,
I
so,
lied. Okay. I lied.
so the main thing here is your answer now has to be measured this way, right?
Yeah.
Okay. Now, if we're in quadrant 3, these would both be negative, yes? The ratio would be positive, which makes sense. Reference angle again? Now, because of the way the answer is being asked, or sorry, the question is being asked, you need to measure this direction. So you actually, look at this, check this out. These two angles are what with each other? 2 and 3.
We all know you're talking.
They land in the same spot, but
I don't know.
co-terminal, right? They're co-terminal. This one is measured this way. This one is measured this way, but they land in the same spot. So how many? 1, 2, 3. Negative 3 pi over 4. Okay. Questions?
Yeah, guys.
All right, graph 4, 6.
So maybe.
All right. So all these, all the trig functions are what we call periodic. Any idea what that means? All the trig functions are periodic.
It's like
They keep
her rate.
They are periods, yes.
they recur what period?
They reoccur.
Over a given period.
Uh-huh. Yeah, they have a repeating pattern, right? Good. So what does it mean? It means they have a repeating pattern. Most simply put, right? I'm not gonna get crazy. Paul, your notes are there on your desk. So I'm gonna just come up with my own. I like zigzag. So here's an example.
Appalachia. All of 76.
That's graphically. So I'm just gonna pretend. Let's just say this is 3. This is 6. This is 9.
It repeats.
Okay. So the periodicity. Kind of a pretty word, right?
Yes.
Periodicity of the graph can tell us some things about the function values. And the last problem on your 4-4 homework was kind of leading up to this. So would you agree that f of 3 is the same as f of 6? Is the same as f of 9, is the same as f of 12, right? You can play the same game anywhere you go on the graph. If I go here, isn't that the same as if I add whatever? So call this x. What would I have to add to x to get to that same spot? 3, right?
Oh, 3.
What would I have to add to get to the top of the mountain? Next mountain.
1.5. Oh, 3.
3, right? So can't we bounce from the different x values from the different?
Yes.
Okay. We add the period on the x, or any multiple of the period on the x. Aren't we going to get the same function value back out?
Yes.
Follow me? So like if I added 3, or if I added 6, or if I added 9, I'm getting back to the same spot, the same function value. Okay? So algebraically, that means f of x plus the period equals what? Sorry? F of x. Now let's do with numbers one more time. That would say like f of 3 is the same as, if I add 3, right? Is the same as f of 6. Is the same as f of 9, etc. Okay? You doing okay?
Yes.
Okay. Don't write this down, just watch and enjoy. Oh, that's awesome. That's good.
Yeah. I normally I would have
Oh man, that's really bad. Okay. Black graph, that's, what is that? Sun.
Yes.
I won't disrespect you and beyond that. I won't, you know why? I don't wanna do it.
What happened to the graph if I did this transformation? Left 2 pi. So wouldn't this red point go here?
Yes.
And then it would just do its thing, right?
Yeah.
Has anything happened?
No.
So sine of x plus 2 pi equals, that's our first identity. Now that's not shocking, because what's 2 pi? Period.
End of sentence.
Oops.
I have a
Uh-oh, it's unaligning. 1 second.
Yeah, I hate smart boards. How come it's always the math
Okay,
teacher's
listen.
smart board that doesn't work?
Just, we don't have to erupt in a crazy conversation. X,
Multiplication
oops,
sign.
That one's worse.
it might be.
Don't worry about it. Not a big deal.
Okay. Now, without drawing it for you, what would happen with cosine? Same thing.
I hate smart boards.
Paul, come on.
All right, and then the only other one we're gonna do. What if I moved it pi to the left instead? So this point becomes here, right? And then it would do its thing. What's the green graph now?
Negative sign.
Negative sign, right?
Yes.
So sine of x plus pi is negative sine. And guess what? Cosine does the same thing. These are the only 4 that we'll need. The other class asked, yeah, could this stuff work for tan and cotan? Of course. We can have similar identities, but we're not going to get into everything. You need a calculator for the next problem.